111. Period 5. 4. 10. Okay. Okay. That's gonna be a problem. This one. Separate. Control yourself. Okay. An inscribed angle is different from a central angle because a central angle goes to the center and back out, and that's why it matches the outside. This time it does not do that. It goes all the way to the other side of the angle. So an inscribed angle is an angle with the vertex on the circle. So not on the center, it's on the circle on the other side. So this is like my vertex B. That's what's opening up to make the angle. The two sides are not radiuses or radii this time. The two sides are chords, which is what we learned about yesterday. So chords are just lines that connect and connect. The vertex is connecting the chords. So an intercepted arc is technically the arc that lays between or what the angle is actually making. So if I'm A, B, C, and that's like an alligator's mouth, like Pac-Man's mouth, waka, 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 waka. Okay, the arc is this portion that it's actually opening up to. So that's called the intercepted arc. It lies between the endpoints of the actual angle. And then the math part that comes along with this, the degree of the inscribed angle, so the degree of the angle is equal to half the measure of the arc. So if my arc was 100, let's keep it easy peasy. If my arc was 100, the angle ABC is not 100. How much would it be? 50, because you're cutting it in half. So this would be 50. Ooh, it's a little small, but that's 50. So the rule is the angle ABC is equal to half the arc. There's my little arc. Sometimes they won't give you any numbers at all. And then you're like, that's weird. Okay. The reason why is because they're giving you a diameter. So a diameter cuts something in half. How much is a full circle? 360. So if this was 360, I cut it in half. How much is half of a circle? 180. The reason why you know that's exactly 180 is because they put the diameter in there. So yes, it's a triangle. And people are like, triangles make 180. Yes, you could add to make 180 because it's a triangle. But the idea is if this is opening up to that, that's 180. The angle that's going in is half of 180. So what's half of 180? 90. So every single time you have a diameter, the angle that's making it is going to be a right triangle, a right angle, because it's a 90-degree angle. So it's a right angle, which means a 90-degree. And then overlapping arcs is the next topic that they're technically going to talk about. This is when you have two angles that overlap each other and they open to the same arc. So if I look at angle ABD, A to B to D, what's the arc that my mouth is eating, like my packing? A to D. Okay, so that opens up to A to D. If I look at the other angle that's in here as well, if I look at ACD, ACD opens up to the same arc. So if they open up to the same arc, what would you know about both angles? Very cool. So they're going to be congruent. So if I know ABC or ABD opens up to the same arc as angle ACD, then that means that the two measures are congruent. So if I knew that one arc was 100, then I could cut it in half to make 50. The other angle would also be 50 because they're congruent to each other. So it sounds like a lot. Kind of is a lot. Let's just do some math. So we're going to skip 6, so you can cross that one out automatically. Let's go to 2. So for 2, I'm given 113 is the angle. I need to find arc DGF. Yeah, because what'd you do? Multiplied it by 2. So if you're given the angle, you're going out, you're getting bigger. So I'm going to multiply by 2. That's going to make 226. If I was given the arc, I would cut it in half to make the inside. So you're kind of thinking I'm multiplying by 2 to get to the outside. I'm dividing by 2 to get to the inside. So 226 is my answer. Let's go to 3. 3 has no number. Great. Everything's going to be fine. It's going to be PQR is what I'm looking for, which is Q. I'm looking for this angle right here. 90. Why? Because it's opening up to 180. Half of 180 is 90. Not too bad. Not too bad. Not too bad. Let's go to number 5. Yes. Brace yourself. Look at number 5. Claire, are you looking for everything this week? Oh. So I'm gonna get it. I don't know to. Oh. Okay. We need to find JKL, which is like on the inside, right? So I gotta find this. So we know that that matches technically. It doesn't match. It's not equal, but we can use something with this arc. How can I find that big arc? Oh, add 65. Good. A circle makes 360. So if this is 53, this is 65, and I subtract from 360, how much is this whole arc going to be? Like in the 200s. 242. That's not the angle. If the arc is 242, how do I find the angle? Divide by 2. So how much is my angle? 121 degrees. Okay, try number 4. Now that we've done a couple. Try number 4. I cut this in half to make the angle. So I would take this number. They're giving me this number. I have to find the arc that goes with it to start. So if I take this, I'm not cutting it in half. I'm getting bigger. So I'm going to multiply by 2. So how much is A to C? 94 because I multiplied by 2. The goal is not to find A to C. The goal is to find B to C. So what's your last step? You could just add to make 180 because it's half of the circle. Yeah. Oh. Because half of a circle makes 180. Because you have a diameter. So this is 180. If you want to put 180 over here, you can put 180 over here. And then you could add to make 360, or you can think that's 180. So add to make 180. So how much is? So I multiplied 47 by 2 to get 94. Because I'm going out, so I multiplied by 2. So what's 180 minus 94? 86. Let's do number 9. Okay, so let's multiply by 2 because you know the inside you're gonna have to multiply by 2, right? So we're doing like 2 times 13x minus 1. But what would that be equal to? 180 because you have a diameter So the angle that it's opening up to, like a mouth, okay, those are your like, that's your like jaw. It's opening up to this whole amount. That whole amount is 180. So I could do 2 times my angle equals 180. So distribute. I do not. Yeah, and I ran out of Dunkin' napkins. I know. What is that? I don't know. Let me check. 182 divided by 7. Oh my gosh. 7. Okay. Let's go to 10. So the whole point is that you're taking your inscribed angle, you're multiplying by 2 to make the outside, or you can take the outside, divide by 2 to make the inside. So do you want to multiply or do you want to divide? Multiply. Okay. So if I take the inside angle and I multiply by 2, 114's little mouth is opening up to this big arc. So if I take 114, I multiply by 2, how much is that big arc going to be? 228. I have another angle that they gave me on the inside. If I multiply that by 2, 7x plus 6, what would that get me? If I take 7x plus 6 and I multiply by 2, what does that give me? Because it's the inside angle. So just like I multiplied this by 2 because it's the angle going out. Dang. So if 114 I multiply by 2 to make 228, I could do the same thing to this angle. This angle I'm multiplying by 2 to make the outside. So that would be like 14x plus 12. Okay. So I have everything. Do I have everything on the inside or do I have everything on the outside of the circle? I have everything on the outside. So how much could I add to make for this one? 360. So you could just combine terms right now, so that way you don't have to write out an equation, but I'm going to write it out. So I'm just adding up everything on the outside and equaling it to 360. Did you take, wait, 7x plus what? Did you subtract these from 360 and then cut it in half? Yeah. And then did you divide by 2? Yeah, that works too. Yeah, so these problems, like, you can do them like 6 different ways. Most people are finding the outside of the circle, like multiplying by 2 instead of dividing by 2. But you have this fine. So what do we get for x? Okay, let's do one more on the front. And then I'll tell you which ones we're crossing out on the front, because then we gotta go back. So you should have number 6 crossed out. Let's cross out 15 and 16 as well, because why not? And then we're on the front, we're still gonna do number 13. We'll set up number 13. And then we'll go to the back. 13 says if the measure of FGH, so the angle FGH is 6x plus 21. I'm going to put that in my picture. Then you have arc FGH, I'm sorry, FJH
is 17x minus 21, 28. They're not equal to each other. Okay, I'd make 360 because I don't know everything on the outside.
Times 2.
Times what by 2?
Or times 6.
Yes. So I'm going to take the inside, the angle, I'm going to multiply it by 2, and I'm going to make the outside. So 2 times 6x plus 21 equals 17x minus 28. So distribute. What's in there? Did we get x? 14. And then you got to plug it back in because you got to find the measure of arc FJH. Nope, not 105. 210. Not one. Oh, what are you talking about? What are you talking about? What? Number 10. How about like the 360 part or the 228? Oh. Oh, is your like math wrong kind of thing? Do you know how I got the equation? No. So because I took each thing and I doubled it. So 114, I doubled it to make the arc that it opens up to 228. This one, because that's the whole point of today's. You double the inside to make the outside. So the inside gets doubled to make the outside. Okay. And then you add them all up on the outside because the whole thing makes a circle. Okay, let's go back. On the back. So on the back is a review of stuff that we've already done. Okay. These ones we're not going to do a lot of because we technically already did it. So these are just, instead of regular quadrilaterals, these are inscribed quadrilaterals. We're not doing the area of them. We're just applying what we learned about quadrilaterals, which is like the rhombi and the rectangle and the square and all that stuff. So when we talked about just a quadrilateral by itself without the circle, it's the same rule. So if a quadrilateral is inscribed a circle, then its opposite angles are complementary or are they supplementary? Anybody remember? Nope. So they are supplementary. Yeah, it is 50-50 shot. So opposite angles would be like angle A matches with what? What's the opposite of C? So they're not congruent. They add to make 180. Same thing with angle B. If I add angle D, no, that makes 180 as well. So you basically need the opposite angle from wherever you are standing. So let's do actually you could do number 1. Let's cross out number 2. Cross out number 3. Cross out number 4. We're gonna do like no. So these ones are very easy. So like 5, E is opposite to what? G. So they would add to make 180. We're not gonna do this problem because you can do this problem by yourself. The rule is if they're opposite of each other, they add to make 180. So you can go back and do that one later. Let's do a harder one, like number 7. Number 7, opposite angles add to make 180. So I know I'm gonna have to use 15x minus 23. What is L opposite? N. So these are opposite of each other. Now the problem is I don't know N, so I need to figure out what N is first. Not 180. So N opens up, okay, to M. N is connected to M. N is connected to O. So the arc that it's making, okay, is not yet.
You add 90.
So if I add 91 and 135, how much is that in total? No, use calculator. 226. Now, N is not 226. N is half of that. 113. So we're going to use 113 and 15x minus 23 to add to make 180 because they're opposite angles.
That's a funny word. Thanks.
So what do we get for x? X equals 6. So most of the ones on the back are literally just adding to make 180 because it's already set up for you. If not, you have to find that angle. So the only other hard one is like number 8. Number 8. You want to just like set it up right now?
Yeah.
Okay, I'm not gonna do it for you, but we'll like set it up. So take a second, look at number 8. You're finding the opposite angles that you're gonna use. You're using obviously J. J is opposite of H. You need to find H. Same way we just did. Mm-hmm. So if I take 50 and I add 96, that makes 146. That's not H. How much is H? Yes. So you're using 73 and you're adding your other angle that's opposite. Okay, I'm gonna come around and harass you for a bunch of papers that I'm missing from you. So I might be looking for 1, I might be looking for 2, I might be looking for 3. Honestly, I don't know. This class is the only class that I'm like awkwardly like behind in.